All right, homework for tonight, worksheet 5, and I'll do the first one here so you have an idea of what kind of detail I'm expecting. A poorly tuned car accelerates from rest to a speed of 28 meters per second in 20 seconds. Make a well-labeled diagram of this situation. Here is such a diagram. You can just draw a dot, or you can sketch a little car or whatever. And we care to think about the time, the position, the velocity, and the acceleration in this motion. So at start and the end, there's a time to consider, a position, and a velocity. And at the final time, there's a position and a velocity to consider as well. And we would assume uniform or constant acceleration, so that would apply throughout the motion. So I put that there. Based on what's given, 20 seconds of motion, reaches a speed of 28 meters per second, starts from rest. Starts from rest means the initial velocity is 0. So you have to carefully read and think about it, and if you sketch out the diagram, it'll help you get that straight. So B says make a well-labeled graphical representation. Well, I'm going to force you into a velocity time graph. Time 0, velocity is 0. And at time 20, velocity is 28. So it's a graph provided here, and I can go to 20 seconds, and if I go by fives, this will be a velocity of 25 meters per second at 30. So 28 will be right there, and I'm going to assume it's uniform accelerated motion. So there is a sketch of the velocity versus time graph. And now I want to find out the average acceleration of the car and how far it travels. I'm going to try to use this VT graph for that. The average acceleration is going to be the slope of this graph, so I'll show the work here. Acceleration is the change in velocity divided by the change in time, and that's equal to 1.4 meters per second squared. And now how far does it go? Well, I'm going to use the VT graph again, and I'm going to calculate the area. It's bounded by the line that describes the motion and the time axis. So my solution for that here is delta x is the area, and here's the calculation and the final answer. So that's how far the car goes during the motion that is described, and that with the acceleration. And this is a good solution, a good level of detail. For number 1, please do similar level of detail work in the remaining problems.